Hi everyone. This video is just to kind of follow up what we were doing in class today with our linear word problems. So we just want to do a couple more practice questions to make sure we're feeling really good for tomorrow's lesson before we move on. So in the first question here, we have three friends who are playing a video game. Charles scored 5 less than 3 times as many points as William. Sophie scored 5 more than twice as many points as Charles. Set up your let statements and determine how much each of the friends scored if their total score was 110 points. So when we set up our let statement, we have to first think about who's your basic person, who's being compared to. So right now, Sophie's being compared to Charles, but Charles is comparing to Will. So really, we're going to let William be the base. So we let William equal W. I could have let William equal X, Y, Z, Q, whatever. Okay? But then now we can get Charles, so we're going to let Charles equal now. Charles scored 5 less than 3 times as many points as William. So 5 less than 3 times, we're looking at 3W for our times and 5 less. And then finally, we have Sophie. So when we read through Sophie, she scored 5 more than twice as many as Charles. So remember, we already have Charles. So that's my 3W minus 5 for Charles. But Sophie, she's unique. She scored twice as many and 5 more. Okay, so we can actually go ahead and simplify Sophie's if we'd like. Because when we go to simplify this through, we'd have distributing 6W, subtract 10, plus 5. So Sophie's looking at 6W minus 5 as her expression. So we have the 3 expressions now. We can go ahead and set those all equal to 110 points. So that being said, we're going to have W, that's for William, plus 3W subtract 5, that's Charles, plus 6W subtract 5 for Sophie, and it's all equal to 110. Now I'm going to combine my like terms. We have the W's here, so we'd end up with 10W. We get our numbers here. We get subtract 10 equal to 110. I'm going to add 10 to both sides, so we get 10W equals 120. And when I divide 10 from both sides, we get W equal to 12. So right now, when I find each of these 3 friends, we already know that William scored 12 points. Okay, so that's done. Now, Charles, we're going to take that 3 times 12, subtract 5. 3 times 12 is 36. Subtract 5 is 31. So Charles scored 31 points. And then finally we have Sophie. So hers, I could plug it to any part of this expression here, but I have like that 6 times 12, subtract 5. We end up 6 times 12 is 72. Subtract 5, we're looking at 67. So that's each of the 3 friends there. And we could double check. 12 plus 31 plus 67 does in fact add up to 110. Okay, so that was the first one. In the second problem here, we have the Mystery Incorporated gang is best known for finding clues to solve mysteries. This past year, Daphne found 17 less clues than Scooby-Doo, while Velma found half of the 11 more than Scooby-Doo. Who found more clues this past year, Velma or Daphne? So this requires us to solve for each person first. Now, each member of the Mystery Incorporated gang is given, in this case, we're going to let Scooby do equal, let's say C, for clues. Okay? So because we're comparing all of our clues to Scooby-Doo, we'll let Daphne equal 17 less clues than Scooby, so C minus 17. And we'll let Velma equal half of the 11 more than Scooby-Doo. So she has C plus 11 divided by 2. Or if you wrote 1/2 parentheses C plus 11 for times, that's fine too. Now, in this case, I just forgot to mention that the total amount of clues was 96. So that's just something that would have normally been the problem. So they have a combined total of 96 clues. So usually it's in the problem. That just was forgotten on my part to throw that in there. But we're going to take all these and we're going to add them up together. And we're going to combine and rewrite a little bit here now. So right now I have 2C minus 17 plus C plus 11 all over 2 equal to 96. Now, we got to be careful when we're rewriting here. So we could do this a couple ways. We could use distributing, like this distributing rule of division here. So it's like having 1/2 C plus 5.5 if we want to do it that way. Totally fine. Then we would just bring down our 2C minus 17 plus this equal to 96. Now when we have something like this, we're going to kind of combine like terms again. So we know we have 2C plus 1/2 C. So if I have 2C and 1/2 C, I could do 2.5. I could do 5 over 2, or I could just do 2.5 C. That's totally fine. You're allowed to have decimals. When I combine that 17 minus 5.5, oops, sorry, negative 17 plus 5.5, we're looking at negative 11.5, and it's equal to 96. So even though we're dealing with decimals, they're nice ones, so I wouldn't freak out just yet. I'm going to add that 11.5 to both sides. We get 2.5C equal to 107.5. And then when we have 107.5 divided by 2.5, we end up with the nice number of 43. Bear with me, I was just getting to the bottom there. But we know Scooby-Doo had 43 clues. Now, that's not what it asked for, so we want to know who solved more or who found more this past year. So we're going to plug that in. So for Daphne, we're looking at 43 subtract 17, and she was a total of 26 clues. Velma, we have 43 plus 11 divided by 2. So we have a total of 54 divided by 2 is 27. So not by much, but Velma found more clues. Okay. Literally only one more, but still more. Now, if I keep going here, there's something called consecutive numbers, or consecutive integers in this case. A consecutive integer is something that just follows immediately after. So if I'm counting like 1, 2, 3, 4, 5, 6, those are considered consecutive numbers. Like 3, 4 comes after, that's consecutive. 5 comes after, consecutive. So I just want to fill in my table here. So I would be looking at 4 in that first blank. 5, 6, 7, 8, 9, 10. Now, integers, remember, they can be positive, negative, or whole numbers. So I could have -3, -2. Oops. No space supposed to be here. But 0, 1, 2. No space supposed to be there. 4. Got those extra spaces in there. Sorry, guys. But they're not supposed to be there. But really, we just have them that they go in that order. So when you think of, I wanted you to think about consecutive for a second because the next problem involves that. We are given 2 consecutive integers that are next to each other on the number line. If I have 8 more than twice the smaller integer, it's equivalent to 10 less than 3 times the larger integer. Determine what both values are. So when we think of this, again, just picture my number line for a second. Okay, an example of consecutive are like 2 to 3. Okay, so if x was equal to 2, x plus 1 would equal 3. Right? Same thing down here. If x equaled -3, x plus 1 would equal -2. So consecutive means we're just 1 away. Even one more time, if x was equal to 0, x plus 1 would equal 1. So when we're talking consecutive, we're always thinking that the larger integer is 1 more than the smaller. So again, now if we're given 2 integers, we can say that let the smaller integer equal x, and we let the larger integer equal x plus 1. Okay, so I'm going to use those two when I try to set up this expression now. So my first part, 8 more than twice the smaller integer. Well, smaller integer, 8 more than twice, so 2x plus 8. They tell me is equivalent to, right? So we know it's going to be equal to. And then we have 10 less than 3 times the larger integer. But the larger was this x plus 1. So 3 times that whole thing, x plus 1, minus 10. And now we're going to just go through and solve this. So we'd have our 2x plus 8 equals 3x plus 3. Subtract 10. I subtract 2x from both sides to get x. I add 7 to both sides to get 15. So my smaller integer is 15, and my larger integer is 16. And that should check out because 15 and 16 are consecutive. They follow each other in the number line. Okay? We're going to do a little bit more of those in class tomorrow. So we're going to keep practicing our word problems, but now we're going to add consecutive integers into the mix. Okay? Thanks for watching, guys, and have a great night.